Hello everyone. So today the problem is again very popular, very common, uh, popular problem which is asked in many interviews, questions specifically in FANG like Amazon, Google. And this is a very interesting problem because this is the problem, data structure problem on Matrix, which helps you to play around with like Adobe's and all those softwares. So for example, rotating an image is the problem. So let's go and quickly check what is this problem statement. Rotate image. So you see, you have your Photoshop, any photo editing software, you can rotate image, right? But behind that, you know what does that algorithm works? So this is the code which works behind that particular rotation. And it is interesting to know, isn't it? So what is the problem statement? You are given a n cross n 2D matrix representing an image, all right? So this is n cross n representing, rotate the image by 90 degrees clockwise. So you need to rotate it by 90 degrees clockwise. So this will come right here. So 1, 2, 3, because you're rotating it clockwise. All right. When you rotate it clockwise, so everything will move um, down. So you have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. So they are very strict in the expectation here that you have to do this rotation in place. So before we go into this problem, we need to first understand, as I always say, that okay, there is a problem. What brute force technique comes in your mind? Discuss, take 2 minutes of time, discuss with the interviewer, and then start writing the code for the optimized solution. It is always very, very important. I repeat again, it is very, very important to discuss the brute force approach, taking 2 minutes of time. I mean, if you are jumping directly to the optimized version, it's good. But if you are start taking 1 or 2 minutes of time and then jumping to optimized, it's super good. All right. So rotating an image, if you see this as a matrix, two-dimensional matrix, and you are expecting this matrix to be like this, so what we have to do here, right? So we can do it in this very simple way. What we can do, we can create a new matrix and copy the elements in the corrected rotated positions. So what we can do, we can just, let's say, create a new matrix called rotated matrix right here. All right. And then let's say we have to rotate. We have to rotate. Uh, so what we can do is that we can rotate the positions. Okay. And two nested loops, and then whatever we want to do. So for example, we want to rotate here, we want to move this 1 to this place, all right, 2 to this place, and 3 to this place. So we just need to play around with ij. Okay, so let's say my rotated matrix, every element here, which is, let's say, matrix of I comma j, in this matrix where it is going. So this 3, let's say 1 is going to this place. It means whenever you have your j is equal to 0 and I is equals to uh I mean this, the position of this is 0 comma 0 1 2 0 comma 2, right? So you can just treat it as j, and then 2 can come out like n minus 1 minus I. So that way you can solve this particular problem by just playing around with the indexes. So let me quickly write this, whatever we have. So for example, uh, the basic skeleton for the question. So it's rotate image. Okay. So now, okay. So now we have main method. Okay. So now what we are doing, we need to first copy paste the input and the. Okay. So now we have our input, logic, output. All right. So in my input, what will be there? So input, I'll just copy this matrix. Here we go. Int, and then I change this to, we go. Okay. So this is my matrix. Logic. Again, as I said, the rotation of an image is very simple when you to go with the brute force approach. Why? Because you can just, what you can do, you can just, let's say, I just would like to highlight very simple. So you can create another array, another matrix, let's say, which is rotated, okay, is equals to the size of, let's say, new int would be n comma n. Let's say n is whatever the size you have. And then what you have to do, you just need two arrays for I, and then inside that you will have another array which is j. And then over here what you have to do, so you have to just do rotated, and then something here would be matrix of I and j. So every element in the matrix ij has to be shifted. So for example, element at zero position, which is at zero position, which is 1, will go to 0 comma 3, right? So when you have ij is equals to 0, then you are expecting something which is like I as 0 but j as 2, okay, because 0 1 2. So what you can do when you are expecting I as 0 but j as 2, so j can be n minus 1, okay, because n will be the total value, and then minus I, and this can be j. Okay, so this formula can automatically adjust everything that you see here. So for example, 2 position, so when I is 0 and j is 1, you're expecting this to move here, meaning I will be 1, and so in that case j will be again 2, so 1 comma 2. So you see here j in the second iteration will be 1 automatically, and then it will be n minus 1 would be 2, I, and I will always be 0. So this is the way we can just rotate everything, but over here we are creating an array, and another two-dimensional matrix which is rotated, and this is what they have said specifically. You see, they said you have to do the rotation in place, okay, it cannot use any extra space. Time complexity for this solution is also O of n square. So we will try to solve this problem in uh, without taking any extra space and doing it in place. So what we can do? So we can rotate the matrix in place by transposing and then reversing rows. So there is a concept which is called transpose of a matrix. Okay. So when we do the transpose of a matrix and then we apply the reversing rows, I mean we reverse the rows, then we get the solution that we want. And how? So let me quickly solve it. So let's do this way. First, I will do transpose, right? So transpose of matrix. So this is something which we do. So before we do this, let's quickly write a formula, which method like rotate image. Okay, and there we pass our matrix. All right, and there the matrix is already sorted, and then we can just S out. Okay, so now what we will do? We will just simply solve this row in matrix. Here we go, and this is going to be arrays dot to string, and there it will be rows. Okay, so what is the logic for this in place rotation? I'll create this method quickly. Okay, we have this method. So what I said, the very first thing that we will do is transpose and then reverse each row. Okay, so transpose. So let me quickly do like n is equals to matrix dot length, And mathematically, if you know, we need, when we do the transport, we have to do like ij is equal to ji. So my first loop will be I is less than n. Okay. And then in nested loop will be j less than n. And then int temp is equals to matrix of I j, and then matrix of I j is equals to matrix of j I, and then matrix of j I is equals to temp. All right, this is the basic transpose what we used to do in our college days as well. Yeah, so we must do it here like I plus 1, because we are just starting I is equals to 0 to I to less than n I plus plus, and this is j is equals to I plus 1. Okay, so this is the transpose the matrix, swap rows and columns. That exactly what it means by transpose. We have to swap rows and columns, and now we have to reverse each row. Okay, so I'll copy this loop again to save time, and this time we are reversing each row. Okay, so I0, there we just put j is equals to 0, and j, let's do it by n by 2. Why we are doing by n by 2? Because we have to reverse each row. So reversing of a single array is very simple. You just go take front and last element and do the reversing till mid index, right? So that's what we are doing here. So ij, matrix of ij is equals to matrix of I, and instead of j it will be n minus I minus j, because we're picking the last element, doing the replacement. And then similarly I just copy this and I paste it here. Okay, so I think that's pretty much all which should work. Okay, so I think if you want to know, I can explain each line why we are doing this. So let me uh, do this, for example, so explain this solution one more time. So again, we do this transpose. Why? So transpose operation, it switches the rows and columns in the matrix. What does it mean? It means matrix ij, okay, it swaps with matrix ji. This steps, it rotates the matrix along its diagonal, top left to bottom right. All right, so ij iterate through the matrix, and then outer loop I goes through each row, inner loop j starts at I plus 1 to avoid swapping elements that are already transposed. No need to revisit already swapped cells, so that is why I just need to do it I plus 1. uh, and then this thing which we are doing is very simple for the swapping. And why transpose? Because transpose actually it aligns the elements in a way that positions the correct values for the rotated matrix. Okay, but in the wrong rows. So after transposing, rows become columns, and this is what exactly we want, right? So and then what we are doing here, we are just reversing each row. So row reversal is very important here, because after the transpose, the matrix needs to be flipped horizontally to complete the 90-degree clockwise rotation. Outer loop I again iterates through each row. Inner loop j only goes to n by 2. Why? Because we have to swap elements from the beginning j and n minus j minus 1 of the row. Okay, so this is the reason why we are doing this. And then other things which you see here, we are doing this all the time because we have to just swap the elements in place. And why reversing the rows is important? Because reversing rows after transposing completes the 90-degree clockwise rotation by aligning the elements in their final positions, right? So without these steps, matrix remains a simple transposition without any complete, end-to-end rotation. So let me quickly run this solution and see how it behaves. So 743158269. and we see the 743. Okay, so 741852963. What wrong I have done? J I less than temp is equal to matrix of ij, matrix ij, matrix I, n minus 1 minus j, matrix. Okay, here we go. So this is the mistake which we have done, and this is also here I. Okay, now okay, so this is all good. So now you see 741852741852963. So let me quickly copy this solution and try to run this. So what is the time complexity here? Time complexity will again be O of n square, but the space complexity here, it will be O of 1 because we are not changing any space, right? So space complexity would be O of 1. Okay. So let me copy this solution and paste it here and run this. It is accepted. Now I submit this. So it is submitted solution.